think we left off, we're going to do 10 on page 225. All right, just for your information, to what? Shan. Okay, I took 10 questions off the first test, 10 questions off the second, and 8 from this chapter. So study those first 2 tests, kind of know how to do the processes that are on them. They aren't the exact question, it's modification of that question. So number 10 here says draw a line AB, choose another point C on the line AB, use your compass and straight edge to construct a line that is perpendicular, passes through C. So it's basically just saying a line. It's a line, so there's no, it's not a segment. And then it says just choose a point on that. Any point, call it C. And use your compass and straight edge to construct a line that is perpendicular to AB, passes through C. And I guess what I'm looking for is a little bit of justification for doing something like this. So what you do is you take your compass and swing an arc with these two would be equal to each other. And then you put your compass at something longer than what that distance was and swing an arc from point A up, and then from point B swing that same arc up. And then what you would have doesn't look right, but you would have this thing. So then the justification would be for that. You've got AC is congruent to BC, and that's, you constructed it that way. And then AD would be congruent to BD, and that's constructed. And then you have that DC would be congruent to DC, and this is reflexive. And then you have the triangle ACD would be congruent to triangle BCD, and that'd be side, side, side. Then angle ACD is congruent to BCD. That'd be corresponding parts. And perpendicular. So when you're just showing it, then you would say angle. I don't know that you have to say that the angles are 90 degrees. You could say CD is perpendicular to A, let's say, to the line AB. and it would be basically the definition of perpendicular. And that would be sufficient to show me that you knew why you could do it that way. Okay, 12. So that you're just given those three independent line segments. And these have definite beginning and ending points is because they're line segments. This one's called A, but it has a beginning and ending point. And this one is B, which has a beginning and ending point. And then C has a definite beginning and ending point. That's and the construct a triangle given the three sides. So what you would do is, I guess that you would initially simply take a line and then on that line you would take any one of those three lines, and let's just take this one, put your compass there, swing an arc for that length, find a point and swing an arc that length, and then this side would be of length C. And I'll just label this as A, B, and that's small c. Then what you do is take your compass, put a point here, swing an arc, and then you could go either to A or B. Put your point here and then swing the arc for that length, however you want. And then you would go to A, put your compass point there, go here, and then go to B and swing your arc. Then what you've done is and it doesn't even look right, but you have established then that this side is B and this side is A. And it's all construction. Now, it will form a triangle as long as the sum of the two sides is, the sum of the two shorter sides are longer than the third side. Because if you look back at trigonometry, if you don't, you have a, when you're doing the law of cosines, you had the ambiguous case was when you found a triangle that had two of the sides didn't measure to be longer than the third side. So the two shorter sides have to be longer than the side C. Otherwise, you couldn't form a triangle. It would be ambiguous. And I don't know whether it would be important to say words associated with that or not. I guess this thing is going to be, and I'll draw it down here. Oh boy. You're just given a side, and they're going to call it, this is C. Now that has to have a beginning point and an ending point, because it's got to be a line segment. And then they're going to give you a pair of angles. One of them. And then they call this angle A and this angle B. So they say construct a triangle given two angles A and B. So what you're going to do is you're going to go to angle A and draw your compass thing like that. Now you'll go either end of that line segment, and I'm going to go over here, and I'm going to say I'm going to construct A here, and I'm going to take that arc that I drew right there, and I'm going to run it right out there. Then I'm going to put a point right here, swing an arc up here, and do the same thing here, swing an arc. And then I'm going to draw just draw a ray through there. And then I'll call this A prime. Angle A prime is congruent to angle A by construction. You've just used the process of, and I think there's a construction thing in this section to copy an angle, construction 2. And then you're going to use that construction 2 to do the same thing here. You run an arc, put your point here, run that same arc over here, then put your point here, run an arc. I didn't run this arc long enough. Put your point here and run a similar arc. And then he'd say, he'd call this one B prime. Angle B prime is congruent to angle B, and that's the construction number 2. So now you form the triangle. And it'll work as long as the sum of those two angles, A and B, aren't greater than 180 degrees. Even if one of them is obtuse, as long as their sum is greater than 180, you get a triangle by that construction method. says use a compass and straight edge to construct a 30-degree angle. All right. And what I'm going to do is I'm going to pick a point out here. And then I'm going to construct a perpendicular to that point. So you set your compass at whatever distance you want, and you strike an arc there and there. And then you run your compass at a larger than that length of arc, and then strike an arc there and there, putting points at these two. And there's a construction that we're using. Construction number 5. So C. CD is going to be perpendicular. Perpendicular to the line AD. That's construction. Okay. Dang it. 30-degree angle. You gotta get. Now, I want to take this arc that I we'll take an arc. We'll put a point right here. We'll run an arc around there, and we'll call
first. I think you need the actual compass to get a proper degree.
I got to think about how I do this. That side. I have to get something so that the one side's C over 2 and the hypotenuse is C. I'm drawing a blank on how I get it.
remember seeing something about 30, 60, 90 triangles and trying
Yeah.
to find them now.
What it is I have to get this side C over 2, and I got to get this side as C through construction. And I can, if I that's what I got to try and I think if I go from here to here with my compass and I draw, and that's going to make every side C. I cannot think of how to do that. I have to have it this way. I got to have it. Got it through construction. I got to have that side as C and this side is C over 2. And what it is this has got to be a diameter the same length as okay.
So there's some information on page 222 about 30, 60 right triangles.
Okay.
You must be on it because it's clearly shown C over 2.
I think what I do is I put my compass here. Put my compass here, strike an arc here, and go up like that. Then the distance from here to here is C. Somehow I got to get that one C over 2. I just cannot. Remember how to do it. And it depends. All 16, 18, and 20 are all related to the ability to get that angle as 30 degrees. Establish the line. Here's the line that you have. And here, get 16. And to this line, we're just going to make a perpendicular bisector. So we're going to pick a point, A. We'll run an arc there, like that. Then we'll lengthen it out, and we'll make an arc here, an arc down there, and then we'll put our compass here and go there and there, and then this line joining these two is the perpendicular bisector of that segment. That's construct a perpendicular to a line from a point, construct a perpendicular bisector of a segment. Okay. So this CD. So CD is perpendicular bisector of AB, that line segment, and that's at construction 6. Okay. Hmm. One. And if when we no, to use the facts.
All line firms.
Constructed right angle. We take our compass from here to here, and then we lay that out, so this length comes right up here, and then then this distance is equal to this distance. So what this is, this length is C, and this length is C, and from here to here, that length is C, by constructing it that way. See, what I did is I put my point of my compass here, went over here and swung an arc up so that BD, this is little c, this is little c. The lengths are all the same. Now then, this line is a perpendicular bisector of AB. Therefore, this length is C over 2, and this length is C over 2. And on a right, this one's a right angle. On a right triangle, when you have 30, 60, 90 degree triangle, the ratios of the sides are opposite is 1/2. This one is the square root of 3 over 2. Pardon me. This one's the square root of 3 over 2. And this is 1. And that's the ratio that this is. This length is C, and this is C over 2. It's 1/2 of that length. Therefore, this angle right here is 30 degrees by construction. Does that make sense?
So you placed the point at B, measured back to the origin.
What you did, what we did is, first of all, we did
I mean, you gotta measure C over 2 somehow.
this point right here.
Mm-hmm.
Let's see, what is E? Okay, we constructed CD as perpendicular bisector of AB. And then that means that you know, BE is congruent to AE. definition of perpendicular bisector, right? And then what we did was we made AB congruent to BD by construction. So I laid my point right here, went over here at the end of my compass, ran that line up where it intersected here, and BD and AD are congruent,
So you adjusted your compass to fit between A and B.
A and B.
Okay.
And then ran it up to D. That made that length, those two lengths C. But what we have is then that because BE and AE are congruent, then you know, BD, BE, and AE are 1/2 of the length C. Right. 1/2 of the length small letter C. This is small letter C. And this distance from here to here is small letter c. So that made each one of these two lengths here 1/2 of it. And then, you know, then we can say that the angle EDB equals 30 degrees because of 30, 60, 90 triangle. It has a ratio of, you know, a 30, 60, 90 triangle has a ratio of the side opposite the 30 is 1/2, the side opposite 60 is the square root of 3/2, and the side opposite the 90 is 1. And what we have is we have C and C over 2 here. So the ratio of 1 to 1/2 is the same as the ratio of C to C over 2. So that's a 30-degree angle. That makes this one a 60-degree angle, right? Because it's a right triangle. So by the that's the construction. You pick a point on a line, do a perpendicular bisector of the point, then you run that length out on that when you did that perpendicular and swing that arc up. And then you get that 30-degree angle. So then the 15-degree angle, if you do that construction on 18, do the construction for 30-degree angle, previous problem.
And you bisect that angle.
Yeah. So what you have is you have that angle that's you have that angle through that construction, and then like you say, you bisect the angle. So you use that construction for bisecting an angle. Bisect an angle, construction 3. So use this and then run your two things out here, and this is construction 3. And so that makes each one of these 15, right?
Mhm.
These are 15-degree angles. Then it says compass and straight edge to make a 75. Well, then what you're going to do is you're going to do the construction on 16. So on 20, dang it. Do construction on 16. So then what you do is you get this and you get this is a 60-degree angle, right? And then you do the construction on 20. 18, where you do this, let's see, it was this one. And you get the 30-degree angle. This would be 30. And then do the bisector of it. And that would give you the 15-degree angle. And now then you would you would do the copying of an angle. So you'd run an arc up there, and you would copy that angle by putting a point here and running an arc out, and then you would go from here down this way on that 15-degree, and you would have copied that 15-degree angle over here. And that would be that construction, copy an angle construction 2. And you'd get a 75. So this whole thing, this would be then a 75-degree angle. Through construction.